Hello students, this is part 8 of unit motion, class 9 physics. In our previous lesson, we have seen there are three equations of motion, namely velocity time relation, position time relation and position velocity relation. We have also seen the graphical derivation of first two equations of motion. In this lesson, we will see derivation of third equation of motion and also solve some numericals based on equations of motion. So let us start. So position velocity relation. Here we have the velocity time graph for uniformly accelerated motion along a straight line. You are familiar with this graph because I have already used this graph in solving or proving first two equations of motion. Now what we do? We draw a perpendicular line from the point B on x-axis which cuts the x-axis at the point C, and again draw a perpendicular line from the same point B on y-axis which cuts the y-axis at the point D. Now we draw a perpendicular line from the point A which cuts the line BC at a certain point G, which you can see here. Now students, you know area under velocity time graph gives us the magnitude of displacement or distance covered by the object. So the area of trapezium OA, B, G, C gives us the magnitude of displacement. Hence we can write distance travelled is equals to area of trapezium OA, B, G, C. Now see students, in this trapezium OA, B, G, C, OA and BC is the parallel lines and OC is the perpendicular distance between them. And we know the formula of trapezium is sum of parallel sides into perpendicular distance between them divided by 2. Hence we can write area of trapezium as OA plus BC upon 2 into perpendicular distance OC. Again we know magnitude of OA is equals to U and BC is equals to V. This BC is equals to V and OC is given as T. So by putting all these values in this equation, we have distance travelled is equals to U plus V upon 2 into T. This is our equation number 1. Now again students, from first equation of motion, we know that V is equals to U plus AT, which can be written as AT is equals to V minus U, and again it can be rearranged as T is equals to V minus U upon A. Now substituting this value of T in equation 1, what we have? We can write S is equals to U plus V upon 2 into, in place of T, we write V minus U upon A. So we have U plus V upon 2 into V minus U upon A. Now students, you know A plus B into A minus B is equals to A square minus B square. So V plus U into V minus U is equals to V square minus U square. And in the denominator we have 2 into A, that is 2A. So we can write S is equals to V square minus U square upon 2A. Again it can be rearranged as V square minus U square is equals to 2AS. This is the required position velocity relation for uniformly accelerated motion. Okay. Now students, there is an additional information which might help you in solving some problems. Suppose there are two distance time graph. One is for car A, which is making an angle of x degree with time axis, and another is of car B, which is making an angle of y degree with time axis. Now can you tell which car is moving fast? So here you will see that the angle x is greater than angle y. The angle x is greater than angle y. So the distance time graph which is making a larger angle with time axis, that indicates the greater speed. Hence here we see that the distance time graph of car A making a larger angle with time axis as compared to distance time graph of car B. Hence we can say that car A is moving fast than car B. Why? Because the angle made by distance time graph of car A is greater than the angle made by distance time graph of car B. Now students, there is a flow chart which helps in determining which equation of motion is suitable to solve a particular problem. So first step is determine which variable you are given values for and which variable you are required to find. For example, whenever you go through a problem, then there are some variables whose value are already given in the problem and some variables are asking to you. Then whenever you determine this, the second step is, do you have a value for each variable in the equation except for the variable that you are required to find? It means when you go through the equation, then if you find such an equation which contains all the variables whose value you already know and also that variable whose value you don't know, then you must use that equation to solve the particular problem. But if the particular equation does not contain the variables whose value are known and also the variable whose value is not known, then you go through another equation of motion. Okay, this will be understand better with the help of problem. So let us solve some problems. So our first problem is a bus is starting from rest with a uniform acceleration of 0.1 meter per second square for 2 minutes. Then we have to find first the speed acquired by the bus and second the distance traveled. Now let us see what are the variables whose value is already given in the problem. So here we can see that the initial velocity is given. Why? Because the bus is starting from rest, hence initial velocity u is given as 0. Again acceleration is given as 0.1 meter per second square and time is already given as 2 minutes, that is 120 seconds. It means we have three known variables: initial velocity, acceleration and time, and we have to find the speed acquired, that is final velocity. So we have to search that equation which contains final velocity, initial velocity, acceleration and time. So let us see, is there an equation? So first equation is v is equals to u plus at. So it contains v which we want to find out. U, its value is already given, a, its value is known, and t, its value is also known. So we can go through this equation, v is equals to u plus at. Now let us determine the speed acquired by the bus with the help of this equation. So we have equation v is equals to u plus at. Again we can write v is equals to u means 0 plus a is given as 0.1, so we can write 0.1 into 120, the time is given as 120. So after solving this we have 12 meter per second. So we find the value of speed acquired by the bus as 12 meter per second. Now let us see the next part. In next part we have to calculate the distance traveled. It means s, because we know in the equation s is equals to ut plus half at square or v square is equals to u square plus 2as. S is what? S is the distance traveled or displacement. So we have to find s. We know the value of initial velocity u, we know the value of time and we know the value of acceleration. So we have to find such an equation which contains initial velocity, which contains acceleration, which contains also time and distance. So is the equation first v is equals to u plus at is applicable? No, because we want to find distance and it does not contain the term s. So we eliminate it. Again we come to the equation s is equals to ut plus at, s is equals to ut plus half at square. So is this equation can be used? Yes. Why? Because it contains the variable s which we want to determine and all those variable u, t and a which value is already known. So we can use this equation. Hence, we have the relation s is equals to ut plus half at square. So it can be written as s is equals to u value is 0 and t is 120 second plus half into, in place of a 0.1, into t square means 120 square. So after solving this, we have s is equals to 720 meter. Our next problem is a train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. So let us see the problem and find out what are the variables whose value is given. So here we see that u is given as 90 km per hour. This is not the SI unit, so we have to convert it into meter per second. And you know that when we have to convert from kilometer per hour to meter per second, we just multiply it by 5 by 18. So we can write u is equals to 90 km per hour, which can be written as 90 into 5 by 18 meter per second, and it comes out to be 25 meter per second. And final velocity is given as 0. Why? Because the train is brought to rest. It comes to rest. It means its final velocity is 0. And again, uniform acceleration is given as minus 0.5 meter per second square. And we are asking for how far the train will go before it is brought to rest. It means how much distance does it travel before it is brought to rest. Here are three known variables: initial velocity u, final velocity v, and acceleration a, and one unknown variable, distance s. So we have to find such an equation which contains all these variables. So let us see. Is the equation v is equals to u plus at is applicable? No, because it does not contain the term s which we want to find out. Again, s is equals to ut plus half at square. It is also not applicable because we don't know the value of t. Now in the equation v square is equals to u square plus 2as, it is applicable because it contains all the variable v, u, a and s. So we use relation v square is equals to u square plus 2as. Then we have distance covered is equals to, it can be rearranged as s is equals to v square minus u square upon 2a, which can be again written as s is equals to 0 square because v is the 0 and u is equals to 25, and again 2 into a is equals to minus 0.5. So after calculating this value, we have s is equals to 625 meter. Our third problem is a stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? Now let us find out what are the variables whose value is given in the problem. So here initial velocity is given as 5 meter per second. Why? Because the stone is thrown with a velocity of 5 meter per second. Hence we can say initial velocity is 5 meter per second. Again, the stone is thrown in upward direction. It means the direction of motion is upward and the acceleration is in downward direction. So we know when the direction of acceleration is opposite to direction of motion, then it is taken as negative. Hence we can write acceleration is equals to minus 10 meter per second square because its direction is opposite to direction of motion. Let small h be the height attained by the stone at the highest point. And we know that at highest point the final velocity becomes 0. So we have three known variables. First is initial velocity, acceleration and final velocity, and we have to calculate the distance. It means we have to find such an equation which contains all these four variables. So let us find. Is the equation v is equals to u plus at is applicable? No, because it does not contain the term s. Again the s is equals to ut plus half at square. Is it applicable? No, it is also not applicable because we don't know the value of time. Now v square is equals to u square plus 2as can be used. So using this relation, we can say 0 square because final velocity is 0 and u is equals to 5. So 0 square is equals to 5 square plus 2 into minus 10, which comes out to be 0 is equals to 25 minus 20h. Again it can be equated as 20h is equals to 25, which comes out to be 1.25 meter. Now let the time taken by the stone to reach the highest point be small t. Again we have the value of initial velocity 5 meter per second, final velocity as 0 and acceleration as minus 10 meter per second square. So we have to find such an equation which contains final velocity, initial velocity, acceleration and time. So let us find out. So we see that the first equation v is equals to u plus at, it is applicable because it contains all the variables. So using this relation, we have 0 is equals to 5 plus minus 10 into t, which can be evaluated as 5 minus 10t is equals to 0, and again t is equals to 5 upon 10, which comes out to be 0.5 second. Now students, there are some questions for home assignment which you have to solve, and in our next video we will discuss the next topic, uniform circular motion. Thank you.